Oh, it's like very.
Yeah, all that stuff's happening today. Let's just stay focused as well as much as we can. Okay, so who's missing over there? Abby? Is Abby in the play? Okay, I think so is.
Is it Abby sick? Abby's got a text her.
Abby's sick?
No, she's like a text her.
Oh, she is in the play, just doing tech stuff, which is very, very important. They never give any recognition and they work so hard. Colin, Alexis, I know she does stuff. Okay. All right, so we're going to start. You're going to wonder what the heck this is doing in this chapter. It's all going to fit together. Hopefully, we'll get it fit together. But we know that x plus y to the first is just x plus y. We know that. We also know, I hope, by this stage of our lives, that x plus y squared, that's a FOIL now. You FOIL that. So that's x squared plus 2xy plus y squared. Right? You've done that one enough that you know that. Now the next one, you probably haven't done enough to have it memorized, but you could do it. This would mean take this answer right here and FOIL it with another x plus y. Would you agree? Yes. You know, you're going to write out all that stuff. And I know the answer is going to be x cubed, 3x squared y. Go ahead and write this down. I'm not asking you to memorize it. And you know what? I don't have it memorized either. There's a pattern here that we're going to try to observe. And believe it or not, that pattern is going to help us with our probability problems. So x plus y to the fourth. X to the fourth, 4x cubed y, 6x squared y squared, 4xy cubed, and y to the fourth. Now again, you know me well enough. My memory is not that good, especially now my allergies are acting up. I got this, my head's like blown up. There's a trick here. There's absolutely a trick here, a pattern. So it says, okay, so what's x plus y to the fifth? Do you see enough that you can at least get started on x plus y to the fifth? What do you think? Ollie, how do you think it's going to start?
So we're gonna take the current problem we have now from the x plus 4 to the fourth, and then apply it to another x plus y.
That's what we would have to do. We have to take this guy right here. If we were doing it by hand, we would have to take this guy right here, put him in a big parentheses, and FOILing times another x plus y. I don't want to do that. I could, and that would give me the answer. Just observe what's happened so far. Can you tell me anything about this? Maybe not the whole line or every number in the line, but can you tell me anything about it? Sophia?
It would start with x to the fifth.
Yep.
And then plus 5x to the fourth y plus 9.
Okay, I'm going to go write down what you say.
9x to the third, yeah, cube squared, and then y squared plus
something, x squared y cubed, and
y to the
I need another one. I'm going to need an x y to the fourth, and then a y to the fifth. So what Sophia has noticed, and again, we got some holes in here. This number actually was wrong, so we just put a blank there. We've got some holes in here to fill in, but what she has noticed is, in all of our expansions, whatever power we're going to, that's what x started with. And then as we went down the row of terms, what happened to those x exponents? They down by 1. Now, when we got to the end, this one is actually an x to the 0. It went 4, 3, 2, 1, 0. But what's x to the 0? 1. So we don't normally write it down. Okay? Now, what happened with the y's? Look at the y's here. Well, this was like our y to the 0, and then the y's were doing the same thing, but they were going up. So Sophia said, I got x to the 5th, 4th, 3rd, squared, 1st, and no x at all. And then I have y, 5, 4, 3, 2, 1, no y at all. I think her letters are perfect. Do you see that pattern? Okay. Now we just have to deal with the numbers. Now, she said, I think this is a 1, absolutely. They all start with 1. And the next one's a 5, because this was a 2, this was a 3, this was a 4, so it's going to be a 5. Now let's look on the other end, Sophia. We know we're going to have y to the 5th on the end, and then what is this guy going to be? Look, this one was a 2, a 3, a 4. Isn't this going to be a 5 right here? So it's just those 2 1s in the middle that are causing us trouble. So I'm going to look at all the coefficients I wrote down. So I had a 1 and a 1, top row. Then I had a 1, 2, 1. Now the problem's getting bigger, so I'm building it out like a triangle. This one was a 1, 3, 3, 1. Now I want you to notice something. Let's just look at this 3 right here. This 3 is the sum of the 1 and the 2. This 3 is the sum of that 1 and 2. So I'm going to put a 1 on each end, and then every number in the middle is going to be the sum of the 2 above it. So this is a 4, this is a 6, and this is a 4. Is that what happened in this row? 1, 4, 6, 4, 1. So what will Sophia's 5th row be? Well, it'll be a 1 on each end. She observed that absolutely correctly. And then what's this number going to be? She already knew that. That's a 5. What's that missing number that we didn't know? What's that one going to be? It's going to be a 10. The next one's going to be a 10. And then we have a 5 and a 1. So there you go. There is x plus y to the 5th power. Just for fun, I know I didn't ask you to do it on the notes there, but what would x plus y to the 6th be? Well, let's get our numbers here. Some of this other stuff. What's the 6th row of this triangle going to be? Starting in with a 1. Okay, this is going to be 6, 15, 20, 15, 6 and 1. So if I'm expanding, and I'll do it up here higher, if I'm expanding x plus y to the 6th, I know the numbers are 1, 6, 15, 20, 15, 6, and 1. Those are the numbers in that row. Every term, I just erased it all, but every term is going to have an x and a y in it. This is going to be x to the 6th, 5th, 4th, 3rd, 2nd, 1st. And if you want to write x to the 0, you can, but that last term doesn't have an x. And then the y's are the same that way. So y to the 6th, yeah, 1 to 6, yeah. Y to the 5th, 4th, 3rd, 2nd, 1st, and no y. Put plus signs in between, and there you go, you guys. You just multiplied x plus y times itself 6 times. Isn't that cool? Number 2. Expand x minus 2y to the 4th. This is exactly the same thing, but I've thrown an extra number in there. So let's see how we're gonna deal with that. Well, we're gonna start, that's a 4. So I'm gonna come over here to my triangle. By the way, this triangle right here is called Pascal's triangle. Blaise Pascal, one of the great mathematicians. He wasn't doing this when he came up with that pattern right there. He was doing binomial probability, like coin tosses. You'll see how it all fits together. It's quite remarkable. But anyhow, that's where we're going. That's where we're headed. First, we got to get through this background. So, go to the 4th row and write it down. So I'm going to write 1, 4, 6, 4, 1. And do yourself a favor. You got the whole page there, the width of the page. Spread it out. Spread it out. Go clear across the page. It's called binomial expansion. Okay, what did I do up here? After I got my numbers written out, I wrote out the 1, 6, 15. Then what did I start doing? Putting in the letters, right? Now, here's the deal, folks. Every one of these is going to have an X. But every one is also going to have a negative 2y. Not a plain y this time. It's going to have a negative 2y. Because that is, I'm going to erase my triangle, that is the factor in the binomial. So every one of these numbers, 1, 4, 6, 4, 1, is attached to an X and a negative 2y. What will be the power on this X right here? 4. And then I will count them down. Now, again, when you get to the end, this is going to be like disappear because anything to the 0 is just 1. So there is an exponent there, but you don't see it because it had a 0 exponent. And then the y's do the same thing from the other end, right? So this is going to disappear. Now, I want you to notice something that happens every time, and it's a good check for you. Look at the exponents in every term. What do you notice about the exponents in every term? They add up to 4, and they always will. Okay, now we got to simplify. These are separate terms. I'm going to go ahead and put plus signs in between them, and I'm going to simplify each term. So what's the first term? That's the 4th, yeah, that one's easy, okay. Now the next one, this is not a subtraction. This is multiplication. So what am I going to get here when I multiply all that together? Negative 8 x cubed y. So my second term is negative 8. This is all multiply. Multiply. Now be careful on this one, because there's a 6 here, but this is not a 2. This is actually a 4. Do you see that? When you put those powers on, you're putting it on the entire y quantity. So this is a 4, so this is going to be a positive 24 x squared y squared. All right, can you figure out this one? What's this one going to be? You're multiplying it all together. What's it going to be? Negative 32 xy cubed. And what's on the end? If you say 2y to the 4th, I'll smack you. It's not 2y to the 4th, it's 16y to the 4th. Remember, everything everything in the parentheses goes to the fourth. Done. There's one more. One more of those. See if you can get it started. I still have enough of my triangle written here. I erased a bunch of it, but I have enough written here. I only need the third row this time. Look, you're expanding to the third power, right? This tells you which row you're going to. So that's these numbers. Okay? Now, Ben, what am I going to put next to each of these numbers? Ben?
2x.
Yep. So 2x goes next to everything. And what else is going to go next to everything? A3y. Thomas, what's the power that's going to go right here where my finger is pointing?
Would it be 0 and then 3 on the other side?
Actually, it's backwards that. The first number starts out with the power. So that's going to be 3 there. And then 2, 1, 0. And then 3, 2, 1, 0. And we just simplify carefully, carefully. So anything with a 0 is 1. So ignore that. What's your first term going to be? 8x cubed. Yep, perfect. 8x cubed. That's all you got. Now be very careful here because you got a 3, but what do you have here? 4. And then you've got another 3. So this one is actually going to be 36 x squared y. You see where that came from? And then here, same thing, we've got a 3, a 2, and a 9. So that one's 54 xy squared. What's on the end? Y cubed. Everybody okay with that? Now, what you have done so far is you've done the entire expansion. So we said, okay, expand this. So you found every single term. We found every single term. In this next set of problems, they're asking you to find only one particular term. So instead of having to write, miles of stuff, you're only looking for one term. Now, think about how you built the terms that I just erased. When you simplified, you had this coefficient from the triangle, and then you had a power of your first thing and a power of your second thing. That's what each individual term looks like. So that's what I'm trying to find for x plus y to the 10th. And I want the fourth term in the list. So if I wrote out the whole thing, very, very big, I would want the fourth one in the list. You should be thinking about something right now and sort of dreading something. Something should be like bothering you. Jeff?
Well, we know what the exponents are going to be.
We can find the exponents.
It's going to be under the 7, or x 7.
So do you see what he's saying? He's saying, I know what these powers are going to be because I know in the first term, if I were writing out the whole thing, my x would be to the 10th, and then in the next term is the 9th, the 8th, and the 7th. So he says, I don't know anything about lots of stuff here, but I know my x is gonna be to the 7th by counting. That's all I did, count down. And if I'm going to the 10th power, and this is a 7, my y has to be to the 3rd. Does that make sense to you? Okay, so what's the bugaboo in this? Abby? Oh my Lord. So, in order to find this coefficient, I need, as Abby said, to expand this to the 10th row. Now, you may or may not believe me here, but the numbers get really big. It gets big. I do not want to do that. So luckily for me, some really smart people came up with a shortcut. Or it's not even really a shortcut, it's an observation. Would you, let's see, what, I had the 6th row here, right? It was 1, 6, 15, 20, 15, 6, 1. Is that the 6th row? I had that here. Would you get out your calculators? And last time we talked about combinations and permutations, didn't we? So I want you to type in your calculator 6C4. Just type that 6C4. And when you get that number, then I want you to type in 6C3. And just randomly 6C0. Are any of the answers that you're getting in this row? They all better be in this row. Because the numbers in Pascal's triangle in each row are simply the combination numbers for whatever row it is. So if it's the 6th row, these are the 6C numbers. The first one is 6C6, 6C5, 6C4, 6C3, 6C2, 6C1, and 6C0. So you can generate the numbers without building the triangle by using the combination numbers. Didn't you get 15 for this one? And you got 20 for this one? And you got 1 for that one. So, I know that the 10th row of the triangle, 10th row, is going to be 10C10. You always start out 10C10 or 12C12 or whatever. And then it goes down. So 10C9, 10C8, 10C7. Isn't that the coefficient I'm looking for? That's the 4th number in that row. So what's 10C7? What? 120. There you go. Done. Problem done. All right, B. We want the 3rd term of this expansion. So we know it's going to have a number. We'll figure out what that is. It's going to have a 2x and a negative y. These are the components of the binomial. So we have 2x and a negative y. And it's the 3rd term. All right. So, which row of the triangle, if I were building the triangle, which row would I be interested in? The 7th. And I know that the numbers in the 7th row are the 7C numbers. So 7C7, 7C6, 7C5. Isn't that the one I want? So what is 7C5? What is it? 21. So your coefficient's 21. Now we gotta put on the powers. Remember how Jeff did that before? We know the first term, the x power would be 7, 6, 5. So my x power is 5. And if my x power is 5, then my y power is 2. And now I simplify. So I've got a 21. What do I got here? 32, x to the 5th. And what's going to happen to that negative? Is it going to stay or go? It's going to go. So 21 times 32, 672. So my answer is 672, x to the 5th, y to the 2nd. Pretty cool. About to get even cooler. Hang on to your hats. Look at number 4. This is Ford. What in the world does this have to do with anything that we've been talking about? We're about to see. When you roll a die, and your goal is to get a 3, when you roll it, you're either going to get a 3 or you're not going to get a 3. Would you agree with that? What's the probability of getting a 3? When you roll a die, what's the probability of getting a 3? 1/6. What's the probability of not getting a 3? 5/6. So you got to start with that. You got to start with that understanding of a die. When you roll it, probability is 1/3, or excuse me, 1/6, you'll get a 3. 5/6, you won't get a 3. Okay. Now I'm going to do this 5 times. Now when I roll a die 5 times, I can get 5 3s, right? I could get all 3s. I could get 4 3s and 1 not. I could get 3 3s and 2 knots, 2 3s and 3 knots, 1 3 4 knots, and no 3s and 5 knots. That's what could happen. I'm going to ask you to make a connection now. These numbers, 5 3s and no knots, 5 and none, 4 and 1, 3 and 2, 2 and 3. What do those numbers remind you of in the problem that we just did? The exponents. Don't they remind you of the exponents? Because in the beginning it was x to the 5th and no y's. And then it went to x to the 4th and 1 y. So if I want, what did it say? Exactly 1 3. That would be this term right here is what I'm interested in. So my 3 probability is 1/3, and I want one of those. And my not 3 1/6. I don't know why I keep saying 1/3. And my not 3 probability is 5/6, and I need 4 of those. If I roll a die 5 times, and I get 1 3, then I'm going to have to get 4 not 3s. So this is like your x and your y. So all I need is the coefficient out in front. Well, I rolled the die 5 times. see how these add up to 5? So the coefficient for this situation would be 5C5. 5 rolls, all 3s. 5 rolls, 4 3s. What's this coefficient going to be? 5C1. I roll it 5 times and I get 1 3. It's 5C1. So now we just multiply it all together. 5C1 is 5. So we have 5 times 1 divided by 6 times parentheses 5 divided by 6 raised to the 4th. Did you get 0.4019? This is called binomial probability. There are 2 things that can happen. I get my 3, I don't get my 3. If I do the experiment 5 times, if I roll the die 5 times, then I'm going to use the 5th row of Pascal's triangle or the 5C numbers. Excuse me. Oh man, I do my whole life never had allergies. Now I got them. Okay, did you get getting that answer? Well, okay, let's try the next one. Find the probability of rolling a die 5 times and getting no 2s. Now, are these numbers the same for 2s? No, that doesn't matter, right? I want no 2s. So I'm going to roll it 5 times, and I want 0 2s. So of my 5 rolls, I want 0 of them to be 2s. So the probability of a 2 is 1/6, but I don't want any of those. The probability of not a 2 is 5/6, and I want 5 of those. Now, does that set up, is that starting to make sense? I'm rolling the die 5 times. I want no 2s, so there's the 2 probability, and it gets a 0. That means I have to have 5 not 2s, so there's the not 2 probability, and I got 5 of them. Did you get the exact same answer? It's kind of cool. Coincidence. I mean, there's a reason it happened, but it's just the way the triangle is situated, the numbers I'm using. No more than 1/4. What does that mean? No more than 1/4. What does that mean? I can get 1/4, or I could get no 4s. So this is no 4s, or, very important word, 1/4. This is 2 separate problems. I am rolling the die still 5 times, so this one, no 4s, is going to be 5C0. I'm rolling it 5 times, I'm getting 0 4s. The 4 probability is 1/6, and the not 4 probability is 5/6. So if I want no 4s, then I have no 1/6, but I have 5 5/6, because I rolled it 5 times. Is that okay with everybody? Now what's this one going to look like? Now I want 1/4, so that will be 5C1 Where's this 5 coming from? 5 rolls. If I roll it 6 times, it'd be 6. The 4 probability is 1/6, and the not 4 probability is 5/6. Now, we actually have already typed those in, right? In our previous 2 examples. Would you agree? We already typed those in? So I know that this answer is 0.4019, and so is this one. What am I going to do with these 2 answers? I told you the other day. Or means add. I'm going to add them together. I want the total probability. The probability of none plus the probability of 1. Remember, when it's an and, you multiply. So no 4s and 5 other things, that's a multiply. But when it's this situation or this situation, I add. So you have about an 80% chance of rolling, if you roll a die 5 times, of getting no more than 1 4. Now, let's see who's thinking. The next one says, at least 1/6. What does that mean? Roll it 5 times, right? So I could get 1/6, or 2, or 3, or 4, or 5. Now, you can do that, but that's a lot of work. Oh, say that again. Say that again. Yes, yes, there you go.
The probability of getting 0 is subtract that.
Exactly. When you roll a die 5 times, and you want at least 1/6, the only thing you don't want is no 6s, right? So he said, what you need, sweetie? Huh? Oh, okay, thank you, sweetie. Okay. I've been subbing for Mr. Hayes' class. Now they're all branding. Okay. So at least 1/6. The only thing you don't want to have happen is to get no 6s, right? So he said, let's find the probability of no 6s. Well, that would be 5C0, 1/6, and that doesn't even do with the 6s. That's the probability of getting a 6. And then 5, 6, 5. So this is that 0.4? Yeah, 0.4019. This is the probability of getting no 6s. So what's the whole rest of the situation got to add up to? What does everything else have to add up to? 1 minus that? Because in a probability problem, don't all of the cases have to add up to 1? So you've got, here's what you've got. There's 6 6s, 4, 3, 2, 1, none. This is what you want. You want all of this. Those all add up to 1. So this is easy to find. We've already found it. So if they all add up to 1, then all of this is going to be 1 minus 0.4019. Does that make sense to you? If it doesn't, then you get to do all of these individual cases and add them up, because that's what you would need to do. Mathematicians refer to this as going through the back door. Instead of finding what we want, we find what we don't want and subtract it from 1. Right? Think about it. If I tell you the probability it's going to rain is 0.2, then you know the probability it's not gonna rain is 0.8. Yeah. Perfect. Patrick, you made my day. All right, number 5. Not that this would ever happen to you, but suppose for a minute that you don't prepare, so you randomly guess on a 10-question multiple choice quiz. Each question has 4 options. Find the probability of getting exactly 7 correct. Now, believe it or not, this is exactly the same format as the problems we've been doing. Instead of rolling a die, you are guessing. What happens when you guess? You're right or you're wrong. That's it. Two things, right or wrong. So the probability of being right is what? On this quiz, if you just guessed at a question, the probability of being right would be 1/4. It's A, B, C, D. So the probability of being wrong will be 3/4. So instead of 1/6 and 5/6, like we had with the die, now it's 1/4 and 3/4. Now, how many times are we gonna guess? 10. How many of them do we want to be right? 7. So our coefficient is 10C7. 10 guesses, 7 of them correct. That means that my 1/4 is gonna get a 7, because that's my right probability. And then what's gonna happen to my 3/4? 3. If you get 7 right, you're gonna get 3 wrong. That's the answer to question number A. I don't think it's very good. Oh Lord, did I type it in wrong? Did you get, I got, the decimal is 0.0031. Is that what you got? So what does that mean percentage-wise? 0.3%? Not very good, right? Not very good. At least 9 correct. Now wait a minute, at least 9 correct means 1, 2, 3, 4, 5, 6, 7, 8, or 9 correct? Oh, no, at least 9 correct means 9 or 10. Oh yeah, that's easy. 9 or 10 correct? So what would 9 correct look like? 10 C9, 1/4 to the 9th, 3/4 to the 1st. Is that 9 correct? Does that make sense to everybody? Or 10 correct? I can't tell. Are you with me here? Are you following where all these numbers are coming from? There's a lot of numbers. 10 questions, 9 correct. Probability correct to the 9th. Probability not correct to the 1st. And then the same thing here, but we want all the questions correct. Okay. This is incredibly small. I got 2.9564 times 10 to the -5th. Anybody else get that? I think I typed it in right. If you're putting them in a fraction form, if you're raising it to a power, the fraction has to be in parentheses, so make sure you've done that. With these, I actually changed them into decimals and typed those in. It was easier for me, 0.25, 0.75. But you can certainly do it with fractions. Make sure you are using parentheses, though, if you're raising them to a power. So tell me, are we good? Anybody not get something up here? All right, last one in this section. At least one correct. So it's 10 questions, and I have to get at least one correct. So stop and think about what that means. That means I could get 1 correct, 2 correct, 3 correct, 4 correct, oh my gosh, all the way to 10 correct. Look how long it took you to type this one in. How many of these would you have to type in? Oh, 10 of them? A whole bunch, right? So let's use Patrick's method. If you want to get at least 1 correct, then what's the only other thing that could happen? I mean, that's almost everything. There's only one other thing that could happen, and that is none correct. So let's find the probability that you miss them all. So 10C0, 10 questions, none correct. 1/4 to the 0, 3/4 to the 10. You guess none correct, they're all incorrect. Well, that's easy to type in, relatively speaking. That is not the answer there. I got 0.0563. Did you get that? That's the probability that you miss them all. So you've got about a 5 or 6% chance of missing them all. So then what's the probability you'll get something right? Lillian?
Do you do 1 minus?
You do. So 1 minus that is 0.9437. I want you to catch up, I want you to think, and I want you to tell me if you got a question. Yep.
For the last problem, could we have done the same thing we just did and done 10C to the second? Like, if we were to get...
This question was what? We're trying to get 9 or 10 correct?
At least 9, yeah.
Okay. No, you can, but it would be harder, because what's the opposite of getting 9 or 10 correct? Getting 8 or less. That's a whole bunch. Yeah, I wouldn't want to do that. I only want to do the 1 minus when it's less work. You got it? Everybody's watching the clock, looking at your watches, looking at your phones, wondering, when do I get out of here? Just stop it. Let's do a little more now. A little more now. Okay, show this is true. Now, I can't remember if I talked to you about this the other day. Did I use that notation the other day at all? No, okay. So, but we did use this notation. So if we had, AC4, we've been using it all day, right? That's a bad choice, I'm doing AC5. So we've been using that notation all day. Another way of writing that is like this. Combinations are used so much in math. You've seen examples, they're used in all this binomial probability. They're used in binomial expansion. They're used all over the place. So there are different notations. This notation automatically means this. Now, did I tell you how you could work this out by hand the other day? Didn't give you the formula for this either? I was delinquent, so let me do it right now. This, remember when I took this class, there were no calculators. But we had to do all these problems, so we had to do them all by hand. So how did we evaluate, these two mean the same thing, so don't let that bother you. How did we evaluate this by hand? Well, this means 8 factorial over 5 factorial, 3 factorial. You sure we didn't talk about this? Okay, well, you know where the 8 came from. And you probably know where the 5 came from. Where did the 3 come from? 8 minus 5. So when you do a combination by hand, it's the first number over the second number, and then also over the difference of the two numbers. Now, again, there were no calculators, so when I was doing this, we were writing out, this is what 8 factorial means, right? That's 8 factorial. We did talk about that. 5 factorial and 3 factorial. Well, it's not bad. I love to complain about when I was a kid and all the hard work I had to do. But this wasn't bad because a bunch cancels out. 3, 2, 1 makes a 6. So 8C5, if I typed it on my calculator, would say 56. 8 times 7, that's all that's left. So, applying that to this, just forget that for a minute. This means this. And I just told you.
Please excuse this interruption. At this time, please excuse the seniors. They should head to the road.